In this video, I'm going to solve this integral, evaluate it from 1 until 2. So how are you gonna solve this? So first, I know that x to the power of 4 minus 1, I can factor it out, which equals to x squared plus 1 times x squared minus 1, like this, guys. And then because this is the square root, I'm going to put the square root as well. And then because these are a multiplication of, because these are multiplication, I can just separate the radicals like so. So I just converted this into this, voila. And then we have this integral, which is just this. I just converted the denominators. And then what I can do here is just see this pattern. This is a very important trick in algebra, guys. If I have a minus b over a times b, right, this is just equals to 1 over a minus 1 over b. Is that so? Well, let's check it out. If I multiply that and that, actually I get it flipped, guys, sorry, like so. I just multiply a with that, b with that, so it's a minus b, and then a times b, so it's gonna be 1 over b minus 1 over a. What is b in this sense? Well, b is the one we're minusing this one, and then for a is the one we're minusing b with, so it's this one. So then I have these values right here. I can just replace this with this, and then we have this, guys. I forgot the dx, so I just replaced everything. I'm going to delete these. Now what I can do is separate these integrals into two integrals that minus each other out. And then for solving these integrals, I have a special trick for you guys. Are you guys ready for this? So guys, I have these two formulas where the integration of this, where a is a constant, and then these are also a constant, is equals to the natural log of x plus these terms down here. Now, how do we get these formulas? Well, it's just using some standard inverse hyperbolic integral, but that's too hard for our topic in this video. So I'm just gonna substitute the values in with these formulas. And then guys, I just substitute the -1 and 1 in these formulas, leaving us with this. So then we have this long answer, but before I substitute the values in, so I have this long answer. Before I substitute the values in of 1 and 2, I'm going to simplify it. Because these are logarithms, I can just divide them, right? So this is just gonna be the natural log of this divided by this, because this is a minus sign. And then as you can see, I have this answer right here. But then after I get this, I'm going to evaluate this from 2 and 1. So first off, I'm going to evaluate it from 2, and then I'm going to find it from 1. So what is 2 plus 2 squared minus 1? That's root 5. So it's just what's that? So 2 plus is gonna be natural log of 2 over 2 plus 2 squared is 4 minus 1 is root 3, and then this one 2, and then this one is just root 5. And then guys, I already can see without even writing 1, the answer is gonna be 0, because 1 plus 1 squared minus 1 is 0, and then the root of 0 is 0, and then 1 plus 0 is 0 divided by 1, so it's just 1. And we all know that the natural log of 1 is just 0, guys, because e to the power of a number, what number is equals to 1? Equals to 0, right? So that's why ln 1 is equals to 0. Also guys, I'm going to change the absolute value here because I know this is a positive number. Actually guys, sorry, I made a mistake. This one, when it's evaluated to 1, doesn't actually just changes to 0. It's because that 1 plus 1 is root 2, so it's just 1 plus root 2, so it's gonna be negative the natural log of 1 plus root 2, like this, because like this is just 1 over, right? 1 over this, but I can just change it to negative. And then because this is a minus, because I'm evaluating the known integral, the definite integral, because I'm evaluating that, it's actually gonna be a plus, because this is actually, I meant minus that, so it's gonna be plus. And then I can just conjoin this with there, leaving us with this answer. So yeah guys, this is the final answer of this integral. So as you can see, the final answer is just a natural log of 2 plus root 3 times 1 plus root 2 over 2 root 5, which in decimal form is just 0.754, and continuing. So yeah guys, thank you guys for watching this video. I hope you all enjoyed it, and goodbye.